Okay, everybody, let's work on finding the general formula for a geometric sequence. This is example 24.3, and what you're going to see is that how we go about it depends on the information that we're given. But regardless, we're going to be using that general formula. Let's write it down next to our example. Here we are. The general formula is an is equal to the first term, a1, times the common ratio r to the n minus 1. And so if we can identify the first term and the common ratio, then we're good. Okay, let's take a look here. In part A, we're given the common ratio r is 4, but we're not given the first term. We're given the fifth term, a5, is equal to 6,400. So what do? Well, we simply plug this fact into this. We're going to use n equal to 5. And then we know that this is 6,400, and on this side we have a1, that's unknown, times 4 to the power 5 minus 1. So this is 6,400 is equal to is equal to a1 times 4 to the n minus 1. Oh, and the n in this case, we know the n is 5, so let's go ahead and substitute that in there. There we go. So this is substitute into the general formula the given information. Okay, what can we do? Well, on the left-hand side, we have 6,400 is equal to, and then this is a1 times 4 to the power 4. Now, the next thing that we can do is simplify that 4 to the power 4. I happen to know that's equal to 256, so 6,400 is equal to a1 times 256. And then if we divide both sides by that 256, then on the right-hand side, they cancel nicely, and we just have a1. And on the left-hand side, we have 6,400 divided by 256. Let's see what it is. I'm going to use my handy calculator. You can use your calculator or work it out by hand, depending on your preference. 56. Oh, and it looks like it goes in evenly. It goes in 25 times. So our a1 is 25. Well, we now have a1. And we have r given to us, so we can go ahead and write down the general formula. It is an is equal to a1, 25, times r, which is 4 to the power n minus 1. And this is our answer to part A. I encourage you to pause the video now, go ahead and work through parts B and C, see what you can come up with, and then come back and we'll work through them together. Part B, a1 is equal to 2/5, and a4 is equal to negative 27 over 20. So interesting. In this case, it seems like the information that they have not given us is the ratio r. We'll go ahead and make a note of it here. B, a1 is 2 over 5. a4 is negative 27 over 20. And as always, our general formula is an is equal to a1 times r to the n minus 1. That's just given to us. Okay. So what do? We're going to substitute once again. We're going to substitute a4. So the n is going to be 4. a4 is going to equal this. And when we substitute it in, we'll have a4, that's going to be negative 27 over 20, is equal to a1, that's given to us, times r, that's the unknown thing, to the n, which is 4 minus 1. So we're really substituting that second value, the value a4 equals negative 27 over 20, into this equation. Negative 27 over 20 is equal to 2 over 5 times r to the n minus 1. Ooh, and what is n? We know that also. N is 4 because this is a4. So to the 4 minus 1. Okay. We need to do a little simplification here. One thing we can do, of course, is just clean up the exponent on that r. So negative 27 over 20 is equal to 2/5 times r to the power 3. And then we want to cancel off that number 2 to the 5th in front of the r. And how do we do it? We're going to multiply both sides of our equation by their reciprocal, by 5 over 2. And multiply here as well by 5 over 2. Okay. Let's see on the right-hand side, the 5 and the 2 cancel. This is exactly why we did it. So on the right, we just have that r cubed. On the left-hand side, well, we can cancel some things here as well. Can we? The 5 cancels with the 20 and leaves a 4 on the bottom. And so that top of that fraction is still negative 27. And on the bottom, we have 2 times 4 is 8. So r cubed is equal to negative 27 over 8. How do we find r? Well, we can cancel off that cube power by using the cube root. So this guy is cube root of r cubed. That's just going to give us r. And that's equal to the cube root of negative 27 over 8. On the right-hand side, the cube root cancels with the cube and just leaves us with r. With a cube root, since that power is odd, we don't have to worry about a plus or minus. It will actually give us just a single answer. It will be the correct answer. Cube roots and fractions, any roots and fractions, work nicely with fractions in the sense that you can split them up into the cube root of the top, cube root of negative 27, over the cube root of 8. And those you can calculate. You can use a calculator to do them, but you can also just think through. Let's start with the denominator. The cube root of 8 this is what number do you have to raise to the power 3 in order to get 8? And that number is 2. 2 to the power 3 equals 8. So the cube root of 8 is equal to 2. If I just recopy this, I'm going to put a 2 on the bottom. And on the top, what number do you have to multiply by itself to get negative 27? Well, if the negative was not there, to the 27, the cube root is 3. 3 to the power 3. 3 times 3 is 9, times 3 is 27. But since there's a negative there, we better make it a negative 3. And you can imagine saying negative 3 to the power 3, and that comes out to a negative 27. So our r is negative 3 over 2. What do we else do we need? We need to know our a1. And then we can just put those two pieces together into our formula. So here our formula is an is equal to a1, that's 2/5, times r, which is negative 3 over 2, to the power n minus 1. So there's our general formula for an, and this is in part B. Okay, let's take a look at part C. In part C, let's go ahead and grab a copy of this one. There it is. Okay. So here we're given a5 equal to 16 and a7 equal 24, and we're not told what r is, although weirdly they tell us that r is positive. We're going to see if we need that along the way. A5 is 216, A7 is 24. Let's go ahead and see what we can figure out here. What we're going to do is, since we're not given the r, we're not given A1, we're given neither of the pieces of information that we need, we're just going to substitute each of these facts that's given to us into our general formula. So general formula, an is equal to a1 times r to the n minus 1. First, we're going to substitute this one in. So for this one, it's 216 is equal to a1 times r to the power 5 minus 1. And for the second one, we have that 24 is equal to a1 times r to the power 7 minus 1. Let's simplify these. 216 is equal to a1 times r to the 4, and 24 is equal to a1 times r to the 6. Now, this is a system of two equations and two unknowns. There are various ways of solving these, but the way I'm going to do it here is substitution. I'm going to take the first one. I'm going to get one of the variables by itself. It looks like the easiest one is a1 to get by itself. And in order to accomplish that, I'm just going to divide both sides by that r to the 4. So what do we have? We have a1 is equal to 216 over r to the 4. And then what do? I substitute that for a1 in the other equation. Substitute. And we get that 24 is equal to 216 over r to the 4 times r to the 6. Okay, it's a little bit of a mess, but I think we can untangle it without too much trouble. Remember that r to the 6 is like r to the 6 over 1. One of the things that we can do here is cancel r to the 4, cancels with r to the 6, and leaves behind an r squared on the top. So, just for clarity, let's write that step down. This says 24 is equal to 216 times r squared. To get the r by itself, you'll notice we only have one variable, and it's an r, so we divide both sides by 216. On the right-hand side, they cancel. We have r squared. On the right-hand side, we have 24 divided by 216. Now, it's a good question. Certainly, we can cancel out of that. I don't know if we can cancel all of 24, but maybe so. Let's give it a try. Does 216... divided by 24 gives us a nice... So it looks like it goes in 9 times, which means we can cancel this, leaving 1 on the top and 9 on the bottom. So this is 1/9 is equal to r squared. Now, to cancel the r squared, the squared off of there, and get r by itself, we're going to take the square root. But the square root, since the power is even, we have to be very careful. When you take the square root to cancel off a squared, there really are two answers, a positive and a negative. So this is square root of r squared is equal to square root of 1/9 plus or minus. On the right-hand side, the r squared cancels with the square root, and that gives us r. On the left-hand side, the square root, this is plus or minus radical 1 over radical 9. We can split that fraction up. And so we get that r is equal to plus or minus 1/3. That's two different answers for r, which is annoying because r needs to be a single number. And here's where we use that fact that was given to us. They told us in the start that r was positive, and because of that, we know that it has to be positive 1/3 instead of negative 1/3. So r is positive, so r equals 1/3. Let me see. We now have our r. We're not done because we don't have a1 yet. But we do have, back over here, we have this formula, a1 is equal to 216 over r to the 4th. And that one we can simplify to get a1 if we substitute this r in there. So let's do it. We're substituting. a1 is equal to 216 over, and then this is parenthesis 1/3 to the power 4. Let's untangle this in order to get a1. I'm going to keep that 216. I'm going to first get rid of the parentheses by applying that 4th power to the top and bottom. That is 1 over 3 to the power 4. 3 to the power 4. Well, you can check it in your calculator. You can do it by hand. But 3 times 3 is 9, times 3 is 27, times 3 is 81. So that should be 81 on the bottom. This is 216 over, big fraction, 1 over 81. Now, we can bring this 1 over 81 up to the top if we flip it over, take the reciprocal. So this is equal to 216 times 81 over 1. 216 times 81, that fits in the category of hard arithmetic problems for me personally, so I'm just going to go ahead and multiply that. And we'll see it's 17,496. And that is our A1 that we just found. Now, we have A1 and we have R, and with those two pieces, we can go ahead and write down the general formula is AN is equal to A1, 17,496, times the ratio 1/3 to the power n minus 1. And that is our formula, for the general formula for the geometric sequence in part C. All right, next time we'll come back and we'll do a little bit of work introducing series.